Good day. Hi guys. We are here for the second experiment. It's called flash drum separator. The designer of this experiment is Bayport Training and Technical Center. This unit, what we have here, is the flash drum separator. We do have additional units of the entire setup. Now, let's see one by one. So this is the main power unit for this experimental unit, and we do have a storage tank. We do have a storage tank for water inside the college, but in industries it's for well fluids. We do have a pump as well as a compressor for pumping both the fluids from the well or from the storage tank. We do have 4 to 5 valves here. The valve type is simply its ball valve. The flow lines which are entering into the unit are two in nature. The first one is the gas or the compressed air inside the college, but outside the college in industry we use for gas. The next one is for the water inside the college and well fluid oil outside the college. That is what sir is pointing to you is the valves. The type of valves are needle ones. The left on the extreme is taking the compressed air, and the right one is for the water pipeline. Both are meeting in the T-joint and it enters into the flash drum separator. We have a nozzle on the extreme side to give off the mixed fluids, both liquid and the gas. We do raise the liquid to a level inside a flash drum separator. What is the reason for it? The reason for it is to have a surface condensation. It means the fluids upon separation can raise the separation efficiency if already there is a fluid in the column. The column name is called flash drum separator. What is going to happen inside the separator? The principle of separation is simple expansion. That how the gas molecules are made, the gas molecules, when it is exposed to more area, it is going to expand and become lighter in density and raise to the top section of the column. What is going to happen at the bottom? The liquid mixture, the part of the well fluid, is going to drop down because density is the concept, and it's going to further enhance its separation because already there is a liquid inside the column. Surface condensation is going to happen. That means the liquid is going to touch already the liquid contained in the flash drum separator and further get condensed and go to the bottom of the section. So here at the middle portion of the flash drum, the better is the separation. And if at all the gas carries a certain liquid droplets, to avoid accidents in the oil and gas industries and also to corrosion, to stop the corrosion, we put mist extractor or mist eliminator. What sir is pointing to you, the white color stuff here inside the acrylic column is a mist eliminator, but in industries it's made of metallic ones. What is the use of that? The use of a mist extractor or mist eliminator is to remove the mist. Mist is a small sized water droplet present in the gas stream. What is the definition of mist? Mist is the small sized liquid droplet present in the gas stream. So the gas do enter the top section where you are able to see a RH meter, RH relative humidity meter. It is also called as a sensor which is connected to the control panel and which has got a digital display. You can know what is the relative humidity before and after. For example, what is the RH? For example, it shows the display 62.2. Roughly I'm telling you the relative humidity. But after we start the experiment, that means when you send in the air and the water, thereby the separation happens in the flash drum, you will be saving a different value. So qualitative comparison of the value before and the value after is going to give you how much is the separation efficiency of a flash drum. So what happens at the top side? The gas do get separate and it enters to the vent, the top section, so which will be connected to another pipeline or a group of pipelines for further processing in industries. Why do we have that vent on the top? Is to let out the gas, all the gases free from water. How it's possible to have free from water? As I've already discussed, it's possible because of the mist eliminator. Before and after values are going to give you the qualitative separation of the flash drum. That means the difference in relative humidity values. Now on the top we have a flange and a gasket which will be closed with a bolt and nut assembly, and you will be able to seal tightly with help of a gasket at the top as well as at the bottom, so there is no leak possible at all. No leak possible at all. This demonstration will only give you a qualitative indication of how much gas is separated from the liquid. In industries, how much natural gas is separated from. Now I'm going to compare the two experimental units. What we saw in our last class was this one. The name of the unit was three-phase separator. The today's experiment is two-phase separator. So then you need to know the difference between these two units. Let me put it in simple words with three factors. The first factor is the number of phases which you are going to separate. On to my right, we have the today's experiment. It's called flash drum separator. It's exclusively designed for separating two phases alone. Gas on the top and the liquid at the bottom. This is a vertical separator. Another name is two-phase separator. On to my left, my left and to your right, we have the three-phase separator. Here, three phases could be separated. Two well fluids. It's not solid. Two liquids, oil, liquid and gas. Gas will be at the top, it exits at the gas outlet, and you have two liquids here. Based on density, you will be able to separate and get the fluids out of the separator. So this is the first factor comparison between two units here, three-phase and two-phase. The second factor I'd like to speak about is the vapor space. If the vapor is less over here and more well fluids are here, then you go in for three-phase separator. If there is a two-phase separator alone, that means in a well, for example, it's a liquid and gas oil well reservoir. So you have only the oil here and the gas here. Then we go in for vertical separator. So it's also about the phases and the vapor spaces. The third point of difference between these two units is the physical layout. That means how much space is going to be taken by this experimental unit or the real unit in industries, and how much this one. This is going to take less space in industries, and this is going to cover up more physical space. So I'm just stopping with three point of difference when you are comparing vertical and horizontal. Hi. Now we are going to demonstrate the experiment, and we are now starting with the power unit. Let us switch on the power unit first. The control panel and the digital display is giving us a reading. The next instruction is to switch on the air first. So the air from the atmosphere is raised up in a compressor and is passing into the first pipeline, the one which you are going to see on your left versus pointing to you. That's the compressed air line. The valve which controls is needle valve. So it is able to let the air inside up to the T-joint. The next instruction, operating instruction, is to switch on the water. The control panel switch on is done. Now adjusting the valve for the proper optimized flow rates so that both the fluids are mixed in the T-joint and as entering into the flash drum separator. I believe you're able to see the flash of the fluids here, so that we are able to change the flow rates of air and water, and you can see the values do differ, and when sir is adjusting the flow rates, you'll be able to see the stream. That's why it's called flash drum separator. It is getting heated up in industries, and both the fluids are going to flash. The meaning of flash means both the fluids are hot and it is flashing onto a column. Flashing, like the camera flashes when you are about to take the snap. Same like that, you have a flash of fluids inside the column. I hope you will be able to see onto the right side the droplets. I believe you are able to see the droplets on the extreme side of the column. It is drenching down. That means the fluids are flashing. The well fluids are flashing into the flash drum, and it is getting surface condensed. That means it hits the surface and falls out into as a liquid. What will happen to the gas? The gas exits at the top. It's as simple as that. You'll be able to see the relative humidity that gives you an indication before one value and now the new value. Initially it was around 62, now I think it's around 68. It is having demonstrated to you how we should run this experiment and what is the principle behind this experiment. Now let us focus on to the reading. The reading, it points the relative humidity. It shows 69. It fluctuates 68.9 or 69.1. That does not matter. The relative humidity is increasing. It was initially 62. Now it is 69.2. We are not going to go into big calculations, but a rough qualitative indication. That means previously it was a lower value. Now it is increasing. That means it says that the humidity inside the tank is differing. That gives you a qualitative indication of the separating efficiency of a flash. Now, having explained the demonstration and the operating instructions, we are about to discuss the shutdown procedures for the laboratory experiment. Shutdown procedures are very important even in industries. Which one to start first and which one to stop. So now we are into the shutdown procedures. First one to switch off is the water. The next one to switch off is the air, because the air can drive away all the contents and keep the fluid pipelines risk free. And the last one is to switch off the control panel or the power unit. That's the end of the experiment. We have now finished the second experiment called flash drum separator, which is a two-phase separator wherein in industries it's used to separate a gas from a liquid. You can copy down the reading, which was also shown to you in the video clip. There's no much detailed calculation about this experiment. Just copy down the values and give the qualitative inference. That's it. Thank you.